this is the endocardium, and this is the subendocardial region, and the characteristic feature of the subendocardial region in the ventricles is the presence of the Purkinje fibers, and this is a bunch of the Purkinje fibers located in the cardiac region, endocardial region. Now, and this is the cardiac cells, myocytes. If you compare these two areas, you will see that the Purkinje fibers are lighter, larger than the ordinary cardiac muscle cell, and also the location is only located in the subendocardial region. Now, you have seen this section yesterday, and in this area, you start from here to there. So tunica, no, sorry, not tunica, endocardium, myocardium, and epicardium. So in this case, you will see the endocardial region lined with endothelial cells. All the structures inside the ventricle and the atria are lined with endothelial cells. The lumen, the valves, the chordae tendineae, and the papillary muscles. You know, the chordae tendineae and the papillary muscles is anatomical structures. Yesterday we haven't described them. So the papillary muscles are projections of the musculature of the ventricles to which the chordae tendineae are attaching. Percussion chordae tendineae, tamam? Chordae tendineae is that band of the fibrous tissue which connects the valves into the papillary muscles to prevent the reflux of the valve into the atrial lumen. Okay? All these structures are lined with endothelial cells. Now, yesterday you have seen this section, and in this section, this is a magnifying section, it's a high power, and the characteristic feature is very clear that the nucleus is large, located centrally, and the surrounding area to the nucleus is darker or darkly stained because of the presence of the more myofibrils in this area. And if you go to see this cell is branching. So this is the branching of the myocyte. The muscle cell, cardiac muscle cell, is branching. Now, if you go to the branching, the two cells are communicating each other by intercalated disc. And the cells actually, they are separated by connective tissue. And if you remember yesterday, we have said not more than 1 to 2 cardiac muscle cells are away from a capillary, which brings the blood for the nourishment of the cardiac muscles. Tamam? So, in this areas, the white areas are the areas of the connective tissue. Now, if you get that cross-section of the cardiac muscle, like this section, what you can see, the lighter areas, as we have said, they are connective tissue, and in the connective tissue, look at there, these are capillaries. And the dark area is the nucleus of the capillary, because each capillary is lined with a single endothelial cell. So, nucleus and the cytoplasm. Nucleus and cytoplasm. So, this is the nucleus and the cytoplasm. So, this is 1, 2, 3 capillaries are in the section. Now, also you may ask for this cell. This is a fibroblast cell because it's a connective tissue. There should be a fibroblast which produces the connective tissue elements in that area. Now, look at the cross-section of the myocytes. And these myocytes actually highly vascularized. يمكن أخذتوه من الفيزيولوجي. The heart is very sensitive to the oxygen. So it means that the cardiac muscle cells, they should have a very good vascularization to bring the blood for the nourishment of these cells. Now, the cavity of the ventricles, as we have said, the corticotendinae are attaching to the papillary muscles. So these are the papillary muscles. Look at there. These are the papillary muscles in the cavity of the ventricle. So the papillary muscles are projections of the cardiac muscle into which the corticotendinae are attaching. And the corticotendinae actually is attaching the valves into papillary muscles. And all these structures, as we have said, they are lined with endothelial cells, with endothelium. Now, this is a lower power of the section in the heart. Now, in this case, the left hand channel, this one, is the aorta. So this is the papillary muscle, and this is the ventricular cavity, and this is the area where it leads to the aorta. And this area on the right is the area where the atrioventricular orifice opening into the left ventricle. And the valves guarding this orifice is the bicasted valve or mitral valve. Tamam? Now, let us see this valve. This is the papillary muscle connected with corticotendinae, and this valve, actually, you will see there is a endocardial lining on both sides of the valve, and the core of the valve is a connective tissue, and there is a piece of the cardiac muscle is extended into the base of these valves. هذا كلام اللي قلنا yesterday. We have said this yesterday, right? So the core of the valve is connective tissue, on both sides covered with endothelial layer of the endocardium, and the base of the valve has a small extension of the cardiac muscle into the base of the valve. إذا واضح عندكم هذا السكشن. This is the left ventricle opening into aorta, and this is the atrioventricular opening of the left atria opening into the left ventricle, and that's the valve which guards this orifice, atrioventricular orifice. تمام؟ Again, branching, striation, intercalated disc, one or two nuclei. This is normally it has one single centrally located nucleus, but sometimes, which is rare, we have binucleated, one or two nuclei in the center of the cell. And the white areas are loose connective tissue, which contains the vasculature for the heart muscle. Okay? This is what? Epicardium, subepicardial connective tissue, myocardium. These are the myocytes. Now, look at there. This epicardium actually is the mesothelial cells, which is reflected from the parietal pericardium onto the heart, forming a visceral layer of the mesothelium of the pericardial layer. Pericardium is a fibrous sac in which the heart is pumping or beating, and the lining epithelia is mesothelium, parietal on the wall of the pericardial sac, and visceral on the wall of the heart, which is forming part of the epicardium. And the potential space between the parietal layer and the visceral layer of the mesothelium is a layer containing a little bit fluid, which is secreted by endothelial cells or mesothelial cells, and this enhancing or facilitating the beating of the heart inside the pericardial cavity. So that area is the area where we are talking about the visceral layer of the endothelial cells, which is reflected from the pericardial layer as a parietal layer. This area, subepicardial connective tissue, you have seen in your anatomy, the heart has a lot of fat surrounding it, and in that area we have blood vessels, coronary blood vessels are running there. So that area is the subepicardial connective tissue, which has more adipose tissue accumulated in this area. And this area is the myocardium. We know the characteristic features of the myocardium. This is the heart chamber. This is endocardium. This is the subendocardial area containing Purkinje fibers. And this is the muscle fibers in the myocardium. Look at there. In this area, these large cells, light cells, lighter in color, are Purkinje fibers, located in the subendocardial layer. Okay. Now, this is a section of the myocardium, and these are the characteristic features of the myocardium. So, this myocardial section, the cardiac muscle in this section is striated. Cardiac muscle cells are branching, striated, branching, back. Cardiac muscle cells are connected by intercalated disc. Characteristic features, striated, branching,
Connected by
intercalated disc. Back.
Central nucleus.
Cardiac muscle have single centrally located nucleus. There is a significant amount of pink stained cytoplasm around the nucleus. Look at there. Any nucleus you look at it, there is a condensed area in the area where the nucleus is located. It means more myofibrils around the nucleus in that area. That's why it gives that darker coloration. Okay. Now, number one.
Endocardium.
Number one.
Endocardium.
Endocardium. Number two.
Subendocardium.
Subendocardium.
Which contains Purkinje itself.
Subendocardial connective tissue. Can you see any Purkinje fibers?
The lighter cell. The lighter cell.
I can't see that like that.
No.
Can you see? Huh? Other? Other? Is there any lighter cell in the Purkinje fibers? Another cell. Yeah? Other cell. Connective tissue. Connective tissue. Can you see any Purkinje fibers in this section? Now, if you look at there, this is not a cell. This is what? The capillary. Look at there. This is the endothelial lining of this structure. This structure is not a Purkinje cell. Come on. This nucleus is what?
The endothelium lining of the capillary.
Tamam? And this capillary is longitudinal section. Longitudinally section. It's not a circular. It is a longitudinal section. So actually I can't see any Purkinje fibers in this section. Yeah, Purkinje fibers. رجاء بدون كلام. أي واحد عنده سؤال يرفع إيده يعني أقدر أجيب أقدر أشرح أكثر بس كلام ما مقبول. This is the Purkinje fibers. Look at there. So you can't see any Purkinje fibers in this, right?
Yes.
And then number 2 is
Subendocardial.
subendocardial connective tissue. And then we have
The most in myelocyte.
myocytes, and that one is epicardium. And we see the flattened nucleus is a mesothelial cell. Flattened, the chiffon, flattened nucleus, they are mesothelial cells on the outer aspect of the epicardium. Now, this is the endocardium, and this is the endocardium. Purkinje fibers in the subendocardial region. Subendocardial region. So this is the connective tissue, subendocardial connective tissue. And that's the subendocardial connective tissue because the Purkinje fibers are there splitting the connective tissue, the upper portion and lower portion. Tamam? So in the middle, a bunch of Purkinje fibers are located there. And then we have myocardium. Then we have myocardium. واضح؟ Okay. Intercalated disc. This is the intercalated disc. Look at there. Intercalated disc. Very clear. Right? Now, if you go to the junctional complex that contains zona adherence or fascia adherence, desmosomes, gap junction to provide connection and connect the ends of the cardiac muscle fibers one to another. Allow muscle action potential to spread from one cardiac muscle fiber to another. وهي المجموعة الأولى صرفنا وقت على هذا الموضوع. راح أسأل نفس السؤال. I will ask now, in the body we have 4 basic tissues, right? Epithelial,
Connective, neuro, muscular.
muscular or connective, muscular,
Neuro.
nervous. تمام؟ بالابثيليال تتذكرون احنا قلنا cell to cell junction. It has what? Zona occludens, adherence, desmosome, gap junction. In the epithelial cells. But now we are talking about the muscle cell, not the epithelial cell. We are talking into the تسمعوني مو؟ أنت آخر واحد تسمع؟ أي؟ Okay. We are talking about the muscle cell and saying that the cell-to-cell junction in the intercalated disc, there is a cell communication like what we have described in the epithelial cells. يجوز يصير ولا ما يصير؟
دكتور
نعم.
هو هنا نحن نحتاج حتى الكهربائي والاكشن بوتنشال تنتقل من العضله للعضله الاخرى بنفس الوقت حتى الكونستراكشن يصير.
That's a curve junction. Okay.
يو حتى كلهم يصيروا نفس الوقت.
ما Yeah, this is what we have described. Tamam? Now, my question is, we have 4 basic tissue in the body. Epithelia, they have characteristic features. Tamam? Muscular, they have their own characteristic features. So on, the connective tissue and the neural tissue. Tamam? Now, the characteristic features of the epithelia, we are now applying on the muscular tissue. How it comes? Yes. شنو يعني تساوي بالبيولوجي؟
يعني اختلاف اصل كل تشو موقع خلال التطور الجنين.
You are there, but it's more detailed. يعني انت يعني قريب للشيء اللي يعني اريد اقوله. اوكي؟ اولا السؤال واضح ولا ما واضح؟ ما واضح. Now, read the characteristic features. Junctional complex that contains adherent desmosome, gap junction. A intercalated disc. Yes.
مو كلهم يجون من نفس الامبريونيك لاير، وعندنا اندوثيليوم، ميزوثيليوم، ولا اكزوثيليوم.
نعم.
فكلهم يجون من الميزوثيليوم لاير مالت الكونكتيف تيشو، فعليهم هذا راح يشاركون بالخواص. شلون عندنا العضلات القلبيه سترايتد.
بس ميزوديرم is responsible بالامبريولوجي اخذتوه responsible for the formation of the connective tissue, muscles and bones, not epithelia. تمام? The epithelia is arising either from ectoderm or from endoderm. هو المشكلة لازم اللي حكيناه ولا المجموعة الأولى لازم أحكي لكم. أخذت الإمبريولوجي. بالإمبريولوجي all the body is coming from one cell. That's a zygote. Come on. All of us, we are coming from one cell. And this cell is differentiating, forming 3 layers: ectoderm, mesoderm, and endoderm. Endoderm is going for the digestive system. Mesoderm going for the muscles, connective tissue, and bone. Ectoderm forming the nervous system. I'm reluctant to say the system, nervous tissue, and the skin. تمام؟ هذا اللي أخذته بالإمبريولوجي. Then we are coming to divide the body into 11 systems. This is the digestive system, this is the nervous system, endocrine, name it, 11 systems. But all of them, they are coming from one cell. Come on? All of them, they are coming from one single cell. So it means the origin is the same. The origin is a single cell, developing, differentiating, forming different cells, tissues, organs, and then systems. Why we are dividing the body into 11 systems? To simplify it for understanding. Digestive system is not a separate system. It is under the influence of the nervous system, endocrine, circulatory, all systems are mixed together, working together to form the homeostasis. أخذتوا بالفيزيولوجي مو؟ بس احنا حاليا نقول this is the muscular tissue, and in this muscular tissue there is a characteristic feature in it, that's the intercalated disc, and this intercalated disc containing junctional complex, and the junctional complex, we said, it is one of the characteristic features of the epithelium. What's wrong is that if we say that this muscle cell is also coming, is that single cell from which the epithelium is coming. You got the interpretation? No? واضح هذا الكلام؟ So, what I'm trying to say, there is no boundary, there is no demarcation between system to system, between tissue to tissue, between the cell and cell. But for the purpose, for the sake of description and simplifying it, we are putting characteristic features, systems, organs, and so embryology is important. Although it is 1 hour in a week, 30 hours in all your course, it should be more than that. Because embryology is the base of the development of all the structures of the human body. تمام؟ هذا الكلام من ان تبدا، لان حكيت ويا المجموعه الاولى لازم احكي لكم. اكو دراسه اللي يتخرجون منها يسموهم دكتور اوف اوستيوباثي. Osteopathy doesn't mean the pathology of the bone. Osteopathy is a science dealing with the body of the human being as a one unit. As a one unit. So they are not describing the body as 11 systems as we are describing it. They are describing the body as a one unit, and in that unit, any disturbance or any deviation from the normal structure, that's a disease, right? So they will bring that abnormality into normal situation. How? Not by medicine, by manipulation. So they have an idea. You may, in the physiology, أخذتوا somatovisceral reflex and visceral somatic reflex. So you can manipulate the heart from the body wall. You can manipulate the liver from the body wall. If you have a pain in the liver or in the kidney, it will be reflected on the body wall. That's the visceral somatic reflex. If you manipulate the kidney from the body wall, it is a somato-visceral reflex. So this is a part of the science. It is ما وصل عندنا للعراق. It is a very nice, a special type of teaching of dealing with the abnormalities in the body to bring them into normal situation. The base of it is embryology. Okay? Anyway. So, cardiac skeleton. The cardiac skeleton we have said 3 parts, right? Annuli fibrosi surrounding what? Annuli fibrosi surrounding the openings in the heart, either great vessels or AV orifices, atrioventricular orifices. That is the annuli fibrosis. Tamam? The second part is that triangular area, which is the trigona fibrosa, which is connecting all these annuli fibrosi. Trigona, triangle, trigona fibrosa. Trigona fibrosa. So now we have two parts of three structures forming the cardiac skeleton into which the cardiac muscles are attached. Annuli fibrosi, trigona fibrosa. Now, if you look at that triangular area, think about it three-dimensionally. When you rock, it goes to the interventricular septum. Interventricular septum. And we said the upper third of the interventricular septum is fibrous. So it is
0 point.
what we have said?
0.4.
Septum membranaceum. Command three structures forming the cardiac skeleton: annuli fibrosi, trigona fibrosa, and septum membranaceum. So these two are atrioventricular orifice. This is the left one, that one is right one, and these two are aortic and pulmonary trunk. الصفحة قلنا الهوم وورك حتى يشوف الليمفاتيك درينج في البرين والبون مارو. يمكن رحتوا على الانترنت لو بس عني رحت. Okay. Now, if you read this, the belief that the brain functions normally without classical lymphatic drainage vessels has been held for many decades. عشرات السنوات كنا نؤمن أنه معقول. On the contrary, بالعكس, new findings show that the functional lymphatic drainage does exist in the brain. إذا لا تمام؟ يعني هذا بالباوربوينت
غلط.
يعني هو this is a new finding. At that time it wasn't wrong. Now it is wrong because this is a new finding. تمام؟ بالنسبة للبون مارو، احنا متى نتكلم على البون؟ نتكلم على البون مارو. You remember from your lymphatic course, we said the bone marrow is bone marrow and thymus. They are the primary lymphoid tissue. Primary lymphoid tissue. إذا كان primary, then we have secondary lymphoid tissue. تمام? Why we said bone marrow and thymus are primary?
Antigen independent area.
Yeah, it's an education center. Yes, it's an education center. ليش الكلام؟ We have said that the lymphoid tissue, the bone marrow and the thymus, they are
Education center.
primary lymphoid organs. Primary lymphoid organs. We have secondary lymph nodes, mucosal associated lymphoid tissue, so on. Now, in this case, In this case, what we have, the bone marrow forms a specialized system cell connective tissue that fills the cavities of the most bones. Yesterday, when in the Google, when I was putting the phrase, does the bone marrow has the lymphatic drainage? This is coming out. This is not the answer for my question, right? So it means escaping from answering. Escaping from answering. But what do we understand? That the bone marrow, because it is the primary organ, it is part of the lymphoid or the lymphatic system. So the lymphatic system, is it possible to ask, is there a lymphatic drainage in the lymphatic system?
أكيد لازم.
Okay, let us go. The bone marrow is highly vascularized but does not have lymphatic drainage. The bone marrow, I put it in the red coloration, look at that. The bone marrow is highly vascularized but does not have lymphatic drainage. The rest of the description is describing how the nutrient artery entering through the nutrient foramen into the bone marrow, supplying the bone marrow and the bone by the blood. So this is a sort of escaping from answering clearly, is there lymphatic drainage or not? But because the bone marrow is part of the lymphoid tissue, so it doesn't need a lymphatic drainage. Because the bone marrow producing all the cells of the blood, tamam? Red blood cells and white blood cells. Going to where? Going to the circulation, blood circulation. And from the blood circulation going to the secondary lymphoid tissue. And from the secondary lymphoid tissue, because the secondary lymphoid tissue, the lymph nodes, they are receiving the lymph from the afferent vessels and releasing the lymph through the efferent lymphatic vessels. So the lymph is present in the lymph nodes because the lymph is filtered in the lymph nodes. So the bone marrow, the production of the cells goes to the circulation, blood circulation, and from blood circulation it goes to the lymph nodes. Tamam? So there is a big area. Nobody can answer us if the lymphatic drainage is there or not, but let us say for the time being, because the lymph nodes, the bone marrow is part of the lymphatic system, it doesn't need lymphatic drainage. أعتقد خلاص